Welcome guys. Have you ever wondered when a part fail in an assembly or a component does not function as expected? The problem often start with one place, which is around the engineering drawing. Why I'm saying this? Because engineering drawing is not just a sketch. It is a technical language used to communicate part accurately and unambiguously. The word accurately and unambiguously. So here is on the screen what we are seeing. This is an engineering drawing. These are the views. These we will call as a projection views of the part, and also there is a title block associated with the drawing. So here is this is actually we would like to call it as the front view, and basically this is the right side view, and here this is a section AA. So there used to be a title block also where a lot of other information which is quite important for manufacturing, just like material or surface finish. So the word accurately and ambiguously I have used earlier. So engineering drawing is a technical language which used to communicate part directly, accurately and unambiguously. What that mean? If we have engineering drawing, the information contained in the drawing should be accurate and it should be unambiguous. And what that the meaning of this word? The meaning of this word is simple. There should not be multiple interpretation. Now the best question is, what is the engineering drawing? An engineering drawing is a technical document provide complete and accurate description of the part. So the word which I have used here, precise and complete description. What that mean is precise and complete description of the part. Precise means after repetitive iterations, the correction of the dimensions. That means the whatever information which is placed on the drawing is after doing multiple repetition what it tells us. So description word tells us a lot of story. A drawing description, complete description means is it used to have images, text, numbers and standardized symbols. So what the meaning of images? In form of images, drawing have view. In numbers category we can put the directly dimensions there, and standardized symbols. Drawing also used to have standardized symbols, and these symbols specifically GD&T symbols specifically, and also some other symbols like dia and degree. These are symbols that mostly drawings used to have. And how? So here is the drawing description used to have what? It used to have the images of the views, the first image, the second image and the third image. And the second thing which drawings used to have is text. You can say that here these are the drawing notes in the form of text that we used to mention here. And the third thing, numbers. These are the dimensions, and these dimensions are very precise. And the whole drawing is should be unambiguous. So it is a very technical document, right? And also the fourth thing that I have discussed, the standardized symbol. And standardized symbols here is run out. We have seen here is the feature control frame, FCF. So these are the standardized symbols. So basically drawing description, the description of the drawing is mainly associated around these four pillars. So the next pillar I would like to say here is what information a drawing used to communicate. An engineering drawing used to communicate several critical type of information. First, it defined the geometry of the part. And what the meaning of the geometry here? Geometry is the shape, size and oral form. So basically information a drawing communicate here is shape, size and oral form, functional relationship and allowable tolerance. So apart from this description, we also used to have three things that drawing used to communicate: the shape, the size, in the orthographic views, in the projections we will able to see the shape, and dimension used to tell us about the sizes, and the oral form image itself actually used to tell us the overall form of the part. And there is a functional relationship that a drawing used to communicate and the allowable tolerance. What are these? Let me tell you. Let me show you guys. The first thing is the term functional relationship between the feature that we have discussed are these, like we have this runout which is given, which is specified here on this surface, and here datum b is given, and datum b is what? Datum b is the axis of this part. So there is a functional relationship, feature relationship between this axis and between this outer surface on which this runout has been specified. So basically, drawing also give the functional relationship between the features in the form of GD&T. So what we have discussed now, the engineering drawing, the purpose and evolution. In addition of the geometry and the tolerances, the drawing also used to have following information. It used to have material specification, heat treatment requirement, and the surface coating. Basically, this information used to be conveyed on the feature control frame and how we can look at it. So guys, as I told before, that this is the title block of the drawing, and this title block, this surface coating, and actually surface coating could used to have into the notes, so the drawing notes also, but the material is mostly used to specify into the title of the drawing, title box of the drawing. And apart from it, surface coating is also used to mention onto the title blocks, either on the title blocks or on the into the notes also. And finally guys, it used to have also some documentation details such as part numbers, revision level, and other identification information, and these also part of the title block of the drawing. For nearly 100 years, engineering drawings were created manually. Designers worked on drafting boards using tools such as T-squares, triangles, and compasses. The original drawings were created on physical media like paper. Copies of these drawings were never produced and distributed, and these copies were commonly known as the prints. Now, what are the modern engineering drawings? Today, the engineering drawings are mainly made digitally. Designers use electronic tools such as computer-aided design software to make these drawings. Even though today the tools and the methods have been changed, the very core fundamental purpose of engineering drawing has not been changed yet. Whether it has been created by hand or it has been created by use of a computer tool, the goal remains the same: to accurately control and record and communicate all critical information required to manufacture, inspect, and assembly of a part correctly. And this is exactly where this GD&T is essential, because the geometry alone is not enough. Function must be controlled. In the next video, we will begin understanding how GD&T enhance engineering drawings and eliminate ambiguity. Thanks for watching. If you like these videos, I want you to subscribe the channel and like the video. And if you want something else in the form of the video, comment just below and I will definitely work on it. Thank you very much.